Hey there, fellow tech enthusiasts. Are you ready to embark on a journey into the future? Today we're diving into the exciting world of the Internet of Things, or IoT for short. It's a realm where technology meets everyday life in the most fascinating ways. Now, IoT might sound like something out of a science fiction movie, but trust me, it's very real and it's all around us. From the moment you wake up to the time you go to bed, IoT is there, making life easier and more connected. In its simplest form, IoT is about connecting everyday devices to the internet. Think your refrigerator, your thermostat, your car, even your coffee maker. Imagine waking up to a freshly brewed cup of coffee, thanks to your smart coffee maker knowing your morning routine. These devices, once isolated, can now talk to each other and to us, sharing valuable information. Pretty cool, right? They can help us save energy, improve security, and even enhance our health. But how does it all work? What makes these devices so smart and interconnected? Well, that's where IoT programming comes in. It's the magic behind the scenes that makes everything possible. We need to tell these devices how to communicate, how to process data, and how to perform actions. This involves a lot of coding, data analysis, and innovative thinking, and how to perform actions. From turning on lights to adjusting the thermostat, IoT devices can automate many tasks. That's what we'll be exploring today. So buckle up and get ready to dive deep into the world of IoT, where the future is now. Now, you might be thinking, Adam, we've been connecting computers to the internet for ages. Indeed, the concept of networking isn't new. We've seen it evolve from simple dial-up connections to high-speed broadband, connecting millions of computers worldwide. But what's so special about IoT? Why is it considered a game-changer in the tech world? You're right, networking isn't new, but IoT takes it to a whole new level. It's not just about connecting computers anymore, it's about connecting everything. First off, IoT involves a massive scale of devices. We're not just talking about a few gadgets here and there. We're talking about billions, even trillions of interconnected sensors, appliances, and machines, all generating enormous amounts of data. This interconnected web of devices is constantly communicating, sharing information, and making our lives more efficient. This data explosion is transforming industries, from healthcare to manufacturing to transportation. In healthcare, IoT devices monitor patient vitals in real time, alerting doctors to any anomalies instantly. In manufacturing, smart machines optimize production lines, reducing waste and increasing efficiency. In transportation, IoT systems manage traffic flow, reducing congestion and improving safety. Secondly, IoT emphasizes real-time interaction. It's not just about storing data, it's about using that data to make instant decisions and trigger automated actions. This real-time capability is what sets IoT apart. Imagine a world where your devices anticipate your needs. It's not science fiction, it's happening now. Your smart home can adjust lighting, temperature, and even security settings based on your daily routine. Imagine your smart thermostat adjusting the temperature based on your location, or your refrigerator ordering groceries when you're running low. These are just a few examples of how IoT is making our lives more convenient, efficient, and connected. So why should we even care about IoT? Well, besides the sheer coolness factor, IoT is poised to revolutionize the way we live, work, and interact with the world around us. For starters, IoT promises to make our lives more convenient and efficient. Imagine a world where your car automatically navigates traffic, your home anticipates your needs, and your healthcare providers have real-time insights into your well-being. Beyond personal benefits, IoT is also transforming industries. Manufacturers can optimize production lines, cities can improve traffic flow and energy consumption, and farmers can monitor crop health with unprecedented precision. The possibilities are truly endless. Now, let's talk about the languages that bring IoT to life. One of the most popular choices is C, a veteran in the programming world. C is known for its efficiency, speed, and low-level control over hardware. Why is C so great for IoT? Well, many IoT devices have limited resources like memory and processing power. C excels in these environments, allowing developers to write code that's both compact and lightning fast. Moreover, C gives you direct access to hardware registers and memory addresses, which is crucial for interacting with sensors, actuators, and other components commonly found in IoT setups. Section 5, Python, the rising star of IoT. While C has its strengths, Python has emerged as a strong contender in the IoT programming arena. Python is a high-level language known for its readability, ease of use, and vast ecosystem of libraries. One of Python's biggest advantages is its beginner-friendliness. Its syntax is clear and concise, making it easier for both novice and experienced programmers to pick up and start building projects. Python also boasts a rich collection of libraries specifically designed for IoT development. These libraries provide pre-written code for common tasks like networking, data processing, and cloud integration, saving you time and effort. Section 6, Head-to-head C versus Python. So, which language reigns supreme in the IoT battleground? Well, the answer, as with most things in life, is it depends. C shines when you need absolute control over hardware, maximum performance, and a smaller memory footprint. It's the go-to choice for resource-constrained devices and applications where speed is paramount. Python, on the other hand, excels in rapid prototyping, data analysis, and cloud integration. Its vast library ecosystem and ease of use make it ideal for projects involving complex logic, data manipulation, and third-party services. Section 7. Our first IoT project, a simple temperature sensor. In this section, we will dive into the fascinating world of IoT by creating a practical and straightforward project. Enough talk, let's get our hands dirty with a simple IoT project. This hands-on experience will help you understand the basics of IoT and how different components interact with each other. We're going to build a basic temperature sensor using Python and a popular platform called Raspberry Pi Pico. This microcontroller is perfect for beginners and offers a lot of flexibility for various projects. Our sensor will read the ambient temperature and display it on a connected computer. This real-time data can be incredibly useful for various applications, from home automation to scientific experiments. It's a basic example, but it'll give you a taste of how to connect hardware, collect data, and control it with code. You'll learn the fundamentals of setting up an IoT device and how to make it communicate with your computer. For this project, you'll need a Raspberry Pi Pico, which is a versatile and affordable microcontroller that's great for beginners and hobbyists alike. A temperature sensor like the DHT11, some jumper wires, which will help you connect the sensor to the microcontroller and ensure that data is transmitted accurately, and a computer with Python installed. Python is a powerful and easy-to-learn programming language that will allow us to write the code needed to read data from the sensor and display it. Don't worry, we'll walk through each step of the process. From setting up your hardware to writing the code, we'll cover everything you need to know to successfully complete this project. Section 8. Setting up your project, what you'll need. First, let's gather our tools and materials. You'll need a Raspberry Pi Pico. This will be the brain of our operation, a DHT11 temperature and humidity sensor. This sensor will capture our temperature readings, jumper wires. These will connect our sensor to the Raspberry Pi Pico, a computer with Python installed. We'll write our code and control the project from here, and a micro USB cable for powering the Raspberry Pi Pico and transferring code. Once you have everything, connect the DHT11 sensor to the Raspberry Pi Pico using the jumper wires. Make sure you follow the correct wiring diagram for your specific sensor. Section 9. Let's get coding. With our hardware set up, let's dive into the code. Open your favorite Python editor and create a new file. We'll start by importing the necessary libraries, including Machine for interacting with the Pico's GPIO pins and DHT for communicating with the DHT11 sensor, Python from Machine import, pin import date import time sensor underscore pin equals sign pin 4 pin dot in sensor equals sign dht dot dht11 sensor underscore pin while true. This code initializes the DHT11 sensor, reads temperature and humidity data, and prints it to the console every second. Save the code to your Pico and you're ready to go. Section 10. Explore, experiment, and build your own IoT world. Congratulations, you've just built your first IoT device. It may be a simple temperature sensor, but it's a gateway to a world of possibilities. Remember, this is just the beginning. There are countless other sensors, actuators, and devices you can integrate into your projects. You can explore different communication protocols, cloud platforms, and data visualization tools. The key is to experiment, have fun, and never stop learning. The world of IoT is vast and constantly evolving, so embrace the challenge and let your creativity run wild.